All right, Tom, take it away.
Hey, hi everyone. Thanks for inviting me to speak today about manufacturing and AI. My name is Tom Lin. I'm a Senior Vice President of Wavicle. Wavicle is a consulting firm based here in Oak Brook, and we specialize in providing data and AI services for a lot of manufacturing organizations, including some here in DuPage County. My background has been in the data space for about 25 years, and I've seen a lot of the evolution in this space. And one of the key things I always like to remind people who are also in the space is that there's typically a hype cycle of interest and investments uh, with um, with um, with the evolution, especially around AI. And what I like to kind of talk about today is what we're actually seeing implemented by companies on the ground when it comes to their investments in AI. Today's presentation, we're going to keep at a relatively high level. We want to make sure you have a good understanding of the key use cases of how manufacturers are leveraging AI today. What is important in terms of the application value, and what are some of the pitfalls we have seen that you want to avoid as you kind of start your journey into AI. And we'll leave a little bit of time for a Q&A. Okay. So I think before we dive into AI, it's pretty important to kind of look at the history because we always see certain patterns of history when it comes to new technology innovations. Right now, we're in what's considered the fourth industrial revolution, and because we're on the fourth industrial revolution, there are really three other revolutions that happened prior to 4.0, and each revolution was really powered through kind of breakthroughs in technology. And each revolution kind of had a big backlash on job displacement, but also opened up new kind of opportunities for economic growth, right? So when you think about going all the way back to the 1800s, the ability, water and steam was the kind of the breakthrough in technology that was powering machines and plants, right? So in Industry 1.0, things like the cotton gin was created, and this machine can do the same amount of work as 50 people. And there was, even back then, a backlash that these machines were taking jobs away from humans. There was even a movement in England called the Luddites, where they would try to destroy these machines. But really, the reality is, the ability of machines to process more goods really decreased the cost of textiles, which expanded the textile industry, and also increased the labor demand for cotton. By the 1900s, electricity was really the breakthrough, right? It allowed mass production of things like cars. Again, like the previous, industrial revolution, this had a negative impact of skilled artisans, but did increase the amount of factory workers needed to run these assembly plants. And there was obviously a big ripple effect to connected industries, such as in construction of suburban homes, highways, and travel. 3.0, which really occurred during the 1970s, was when computers and software came into the factory. This allowed basically faster production with less people. So the impact here was in factory workers. But it did increase the demand for software development and machinists, right? So now we are in industry, what you probably heard a lot of times called Industry 4.0, which has occurred somewhere around the 2010s, still occurring now, and this is where a lot of interest investments are coming in. And the breakthrough here in Industry 4.0 is really a combination of four key capabilities. The first is the Internet of Things, or basically sensors that capture data. This data being able to be processed in the cloud, and then AI algorithms to be able to understand and take action on that data. So the whole point of Industry 4.0 is using these technologies to create customized product at a lower cost and higher quality. And like all other revolutions, there are also obviously going to be impact to jobs in terms of being able to automate some of these repetitive tasks through AI. But at the same time, like all other revolutions, there are also new opportunities. We are seeing more demand for analytical digital workers as well as creative workers. We as a company, for example, have benefited in terms of our investments in our solutions around the space, and where we're seeing kind of a lot more demand coming our way because of the trend towards these type of adoption of AI and cloud. So what's kind of driving this investment into Industry 4.0 in AI? I think it's important to kind of understand some of the economic challenges that most manufacturers, especially in the U.S., are facing. Trade is probably currently the most impactful external factor, right? As all of us have seen through the news, the impact of tariffs is increasing cost of raw materials right now. The projection is a 5.5% increase in raw material, and prices increasing about 3.6%. Right. At the same time, manufacturers are dealing with labor shortages. As boomers are continuing to retire, they're not really being sustained or replaced by later generations. So we're projecting about 2 million positions that can't be fulfilled by 2030. And on top of that, right, there are regulatory and compliance pressures, things around being more, making sure that your manufacturers are performing more sustainable practices, reducing emissions. For those moving into the consumer space, data privacy becomes a very big part of how they manage their operations and data. So a lot of kind of external and internal factors are really big challenges. So when it comes to the investments that manufacturers are currently making, and this was done by Rockwell Automation this year, the top 4 that came up were around cloud, AI, quality, and cybersecurity. This is not very surprising because each of these 4 areas is really to help address some of these macroeconomic challenges that manufacturers are dealing with. And so what they hope to, when the National Association of Manufacturers did a survey about why are they making investments into AI, these were the top drivers. And these are things around how do I reduce the cost of my operations? How to improve my operational visibility, responsiveness? How can I use AI to improve my process? How do I use AI to compensate for labor shortages and improve quality of my products, right? So if you think about from very kind of high level, these are really why these investments are being made into Industry 4.0 and AI. So before we dive into specific AI use cases to kind of address the challenges, I think it's very important that we understand terminology because I think there is obviously a lot of information out there that talks about AI, and we try to ground it back to kind of the key terminologies of how it works. I won't go into the technical details of this in this call, but it's good to at least ground you to some of these key terminologies, right? So AI in the most simple way is really a system that, given the objectives and data, can generate predictions, recommendations, and decisions, right? And really where manufacturers are starting to see the use of AI is really in automating repetitive tasks, optimizing decision-making, streamlining operation, and improving data quality. Okay. But that's kind of an abstract kind of understanding, right? So I think what's also important to understand is what are the different components of AI and how they would actually enable some of these outcomes, right? So for example, a very common use case that we have seen from our customers is basically trying to figure out, like, can AI help me better predict demand for my products? And so I'll try to walk you through kind of the different layers how AI typically would do that as an example. So within AI, there's something called machine learning. And machine learning is basically a way by which AI can recognize patterns in the data to make predictions. So if you're trying to, for example, predict the demand of your products for the next 12 months, what AI can do is look at previous year sales, look at seasonality to create that forecast, right? So it's a very simple way of just being able to look at a vast amount of data, look for the patterns to predict the future demand. But it's not, that in itself is, I would say limited, because what you really want to get down to is what we call deep learning. If you think about people who do demand forecasting, it's typically done by a demand planner. The demand planner has to look at a variety of different factors to make a demand, right? To figure out what the forecast is. They have to look at, for example, customer sentiment. They have to look at promotions. They have to look at a lot of different factors. And what deep learning provides you is basically it mimics reasoning like the human brain, being able to look at a lot of different factors to predict the demand. That's what deep learning should be able to provide you for this example. Now, within deep learning, there are multiple models. The most popular, most successful model that I think everyone has heard of is around generative AI. And it's a type of deep learning model that creates content based on questions you ask. So what's innovative about this is if you ask a generative AI model, for example, that if tariff rates increase by 50% for copper, which is basically what was announced yesterday, and I pass on this cost to my customers, how does that impact my demand for the next 12 months? Generative AI, based on, if you were to build a solution around this, would be able to give you that answer. And then the last piece here is what we call agentic AI. Now, agentic AI is built on top of Gen AI to basically take actions based on the goals you give it. So, for example, if you could create an AI agent that says, please improve my forecast accuracy for my most profitable SKU, what the AI agent should be able to do is be able to look at your sales data, inventory data, external factors to really provide a forecast that you can interact with. It will also then interact with your sales team, finance team, and supply chain to kind of align on these forecast assumptions. So I think what's key here is like, all these are just components of the broader umbrella of AI, and there are, specific kind of methods by which, these use cases can be enabled. So if we go back to kind of the macro challenges that we talked about in the previous slide around labor shortages, global trade, operational costs and regulatory pressures, we're starting to see some innovative AI use cases to help address some of these challenges. The first one is around trade uncertainties and cost pressures. Demand forecasting, which we talked about, is probably one of the most important use cases here because it really drives down everything downstream. You can be the most optimized manufacturing processes, but it would not really matter as much if you overproduce or underproduce the products that your customers actually need. And where AI kind of shines here is that it can look at not just your previous year's sales, but a lot of external factors to be able to figure out what your future demands will be. Tariff intelligence is a pretty interesting use case that we're actually currently testing on the market. And this is really helping our clients, navigate some of the tariff impacts in terms of understanding tariff impacts to product margins and how you can leverage potentially like AI agents to help find alternative suppliers that are not as heavily tariffed. Right. And point of all these are specific to help improve your forecast accuracy, find ways to reduce your cost through diversification of your suppliers. For labor shortages, some of the kind of innovative use cases that we're seeing in the market right now is around predictive maintenance, digital twin, and knowledge democratization. So predictive maintenance is typically the most common use case that manufacturers typically test out when they are going down the space, and it's really to predict and prevent equipment failures. And so the goal here is reducing downtime and also relying on fewer operators when it comes to maintenance of capital assets. It does that sometimes through a digital twin, what we call a digital twin production simulator, and this is really creating virtual models of production processes to optimize kind of resource use and reduce reliance on manual oversight. And the third piece here around use cases for labor shortages is around knowledge democratization. This is basically one of the more lower hanging fruits for those trying to get into the generative AI space. A lot of the information, for example, that enterprises, including manufacturers, have is really locked up in unstructured documents, meeting notes, and what RAG AI, or what's called retrieval augmented generation, is allows you access to information through like a chatbot, so similar to like a ChatGPT, and the combination of these kind of use cases is really to help reduce downtime, improve productivity for your workers. Operational expenses, visual AI is probably one of the most common use cases here, and this is really leveraging computer vision to detect defects faster than manual inspections. For example, Foxconn has really adopted this technology to reduce inspection times by about 30%. Another area of investment that we're seeing also is around energy management, utilities optimization. And this is really using AI to analyze kind of energy consumption patterns, optimize your HVAC, lighting, and machinery energy to kind of lower your utility costs and avoiding kind of peak demand penalties. And then lastly, around regulatory pressures, one of the key areas here is for manufacturers kind of moving towards more of a direct-to-consumer model. Data privacy has become very important, but not traditionally easy to manage. So here you can leverage AI to kind of scan a variety of your data storage systems to see if they are adhering to any of the GDPR and CCPA data privacy requirements and flagging any type of potential remediate suggestions as a result. And then lastly here, around sustainability compliance reporting, this is another area that we're seeing some traction in, is basically consolidating things around carbon, waste, water, and energy data for automated sustainability disclosures. And so this allows you to get compliance with SEC climate rules and greenhouse gas protocols in a more automated way. Right. So these are just kind of some examples of where AI use cases are helping address some of these macro challenges that manufacturers are facing. But when we kind of look at what is happening in the ground with some of clients or manufacturing companies who are actually implementing this in the field, we tried to bucket this in what we call like kind of true value, potential value, and what's considered experimental. Some of the things that we're seeing actually being implemented at scale are in these three areas. Predictive maintenance is again, one of the first use cases that has heavily leveraged AI. And one of our clients, for example, is Magna. They are a manufacturer of car parts in North America, and they have fully adopted predictive maintenance to reduce the unplanned downtime for one of their plants that deals with stamping car chases. And so this has allowed them to extend kind of the machine lifespan and kind of lowered some of those type of maintenance costs. Some of the potential values and this is probably where you probably see a lot more of this on your LinkedIn feed, right, is the agentic AI use cases with human in the loop. And this is where you're leveraging AI agents to do things such as, create the demand forecast, but then you still would want a demand plan to review those forecasts before you convert it into demand plan. Some of our clients who have implemented this still have kind of embraced that concept to fully test out whether the AI agents can create the forecast before fully deploying it into their systems. Digital twins and workforce augmentation are also still in the, depending on the maturity of the organization, something that is being deployed, I would say, in limited scale. And then what we call experimental are the use cases that has a lot of, I would say, hype because of how transformative they can be. But I would say it's not that the technology itself isn't not usable, but there are some basically unrealistic expectations on the ROI. Things like dark factories, fully autonomous factories without human involvement, kind of relies on the concept that AI, robotics, and IoT work seamlessly. And really, when this has been implemented, I think Tesla is probably a good example, as well as a Chinese manufacturer, Fanuc, is that it still required human intervention. It's not really there yet. Plug and play AI solutions are another area that you just have to be a bit more cautious about. And this is really where you create AI solutions that works for any situation. In most of our AI implementations, there usually is a requirement to do some significant data preparations in tuning before anything can become usable. And so while plug and play sounds great, we just really haven't seen that really successfully implemented yet. Not that it can't happen in the future. So when it comes to the challenges of implementing these AI use cases, we looked at some of the research. This came from RAND research as well as Gartner. Is that about 80% of AI projects fail to reach the intended value, and the failure is not meant that the solution itself failed. It's just that it's typically isolated through what we call a proof of concept that doesn't really scale within the organization to really get that value. And when we kind of probed into, what are the things that's preventing or is causing this kind of high failure rate, there are really 4 areas that we're seeing consistently, and it's kind of backed up by the survey and research. Is that the data management and data security tends to be the #1 challenge. And this is typically, if you think about how AI works, is that the model works as good as the data you feed it. And so if you are feeding it poor data quality, the outputs that you get is something you may not necessarily trust. So the investments into improving the quality of the data is typically foundational to enabling a lot of these AI solutions. The second area that is challenging for a lot of large enterprises is really the concept of data silos and disconnected systems. So if you think about, large enterprises have multiple ERP systems, multiple CRM systems, multiple MES systems. Some of them have a hard time in supporting real-time data ingestion. The amount of effort to be able to pull data from a variety of different sources into a data platform that can be leveraged for AI tends to be a higher cost than originally anticipated, and that's something just have to be kind of factor in when it comes to these type of projects. Adoption and change management is another kind of area that is challenging. There sometimes is workforce resistance to some of these AI-driven changes. There's also, upskilling required to take it from, let's say, your data science analytical teams into your operational teams, and some of that cultural misalignment of what you expect to get out of these solutions versus what people actually use, right? So it's important to kind of factor that in when it comes to the implementation of these AI use cases. And then lastly, is really what we call the scaling and productionalizing of these POCs. Here, half of AI projects tend to fail at this point because you may have a very good kind of proof of concept that approves the value that you want to implement, but you have not really necessarily factored in kind of the cost of scaling it out to the rest of your organization. The estimation not being upfront is something that we highly encourage, because one use case for one specific application may not scale well when it comes to a fully productionized solution like these. So when it comes to really getting started with your AI journey, we kind of experimented with kind of what is the right steps. We as an organization, we have implemented quite a few of these type of solutions. And when we think about kind of, what if we had to kind of think about the 5 steps we would take when we recommend, manufacturers who are looking to, go into on this journey is really in these areas. One is really aligning your AI needs with your business strategy, right? So a lot of times we have seen situations where there's a lot of excitement to make investments into AI, but it's not really tied back to what your organization is trying to do. So this alignment is pretty important, because without that alignment, it's going to be hard to kind of sell it beyond the initial POC. The other key part here is around what we call use case prioritization. As you've seen in the previous slides, there are a lot of potential use cases you could potentially implement, but not all of them will provide the same necessary value that you want. Being able to kind of prioritize that based on your overall kind of corporate strategy is going to be important from an adoption standpoint. The third piece here is what we call the building a robust data foundation. This is where a lot of investments are being made today, because this is the ability to really connect a lot of your disparate data systems into a data platform that's going to be feeding your AI solutions. You want this thing to be repeatable, automated, with high data quality, with high governance on things such as data security. Those are all the kind of foundational things we always recommend, to be able to sustain and build multiple AI use cases. The fourth part here is what we call the governance framework and AI ops model. So when you think about AI security guardrails, there are a lot of considerations that you have to think about when you think about your AI governance. Who should have access to this? What type of data? What type of security model we have to implement? Those are all kind of key decision points when it comes to this governance framework and AI ops model. And then the last piece here is really around scaling and optimizing AI across your enterprise function. And this is not necessarily a technology scale, right? It's not simply pushing your AI solution into a production environment. What we mean by scaling and optimizing your AI across your enterprise function is that is the tools you're giving your enterprise actually being trained by your end users? Do they kind of understand how it can be used and when it may not be as reliable? And part of this is training, part of this is kind of change management, and part of it is also technical. And so what we try to emphasize is that you have to kind of consider all three when we think about scaling and kind of optimizing AI across your enterprise function. So this is kind of a very high-level overview of where we're seeing the AI use cases being implemented within clients that we're working with, as well as some of the pitfalls and kind of best practices as you kind of want to go down this AI journey. There's obviously a lot of details for each of those use cases that we talked about. Each of them could be probably its own session. But for today's session, hopefully, I are able to give you kind of at least an overview of how we got to where we're at. What are the use cases we're seeing some value in the market, and kind of how you can potentially go down this journey if you are getting started with AI. So I will pause there for Q&A.
Okay, Tom, thank you very much. That was fantastic. If anybody has a question, you have two choices. You can type it in the chat, or you can unmute yourself and ask Tom the question. This recording will be sent out to everybody, so you will receive it. Tom, are you able to share the presentation?
Yes.
Okay, so when Tom sends me the presentation, then I will send that on as well with the recording to everybody. All right. We'll give it a few minutes here, Tom. All right, Tom, we gave it a few minutes. So, yeah, I always take it. That means you did a great job. And thank you to Wavicle Data Solutions for always supporting Choose to Page. We really appreciate it. And Tom, thank you for the very informative presentation.
Thank you all.
All right, everybody, have a great day.